I just want to talk a little bit about what I think is some people misusing the term singularity, particularly in reference to objects like black holes. It goes like this. You have a singularity. It's supposed to be a gravitational singularity like a black hole. It's supposed to be an object that has infinite density. It has zero volume. However, the contradiction is that the gravitational force point at which you reach the cutoff so that you can have an event horizon, so you have a black hole, is not necessarily large enough gravitational force to actually create a singularity or a true singularity. It goes like this. You have with small atoms, like hydrogen, you fuse them together, get helium, it's an H-bomb, it's what happens in the sun. A small amount of the energy goes in, a more larger amount of energy comes out. The difference in energy is a conversion of mass into energy in the fusion process. And that keeps going as you go up and up and up, until eventually, around iron, it begins to take more energy to cause the fusion than you get out of it. And it takes more and more energy to fuse. In the beginning, it's going that way, and then later on, it goes the other direction, which is why we have, say, fission bonds, because as the atoms get bigger and bigger and bigger, they are more stable. The ground state is more to be small, so it's easier for them to go down and release energy that way than it is to keep pumping more and more energy and force to force them into ever bigger atoms. When you try to take, say for instance, helium-3 and uranium-238, there's about 238 times more nuclear binding energy net in uranium than in helium-3, but it doesn't have that much more mass. It only has about 79 times more mass, but 238 times more nuclear binding energy. So you can see that trend toward larger atoms, more and more energy or more and more force to get them together. Now, the consequence of that is that if you have, say for instance, stars doing fusion, hydrogen and helium and so forth, as big as that is, with as much energy as it is, the largest stars do not have enough gravitational force to put 600 hydrogen atoms into one big atom. They just don't have the force to be able to cause that kind of fusion. And yet 6 grams, roughly, of hydrogen is more than 6 with 23 zeros behind it of hydrogen atoms. So this tiny little 6-gram mass has completely different amount of atoms in it, beyond the gravitational force of those objects. And long before you would ever reach the point of being able to get even that 6 grams of hydrogen into one big atom, you would have enough gravity. You could potentially have enough gravitational force to have a black hole and create an event horizon. But you're not a singularity because you have volume, this atom. So there's a bit of a contradiction there, and that's one of the reasons I think it's being misused. Another issue is that to then go past the atom stage and say you want to take all of the protons of that 6 grams of hydrogen, and you want to squeeze all those protons, those 6 with 23 zeros behind it, protons, and you want to squeeze them all into one giant proton. That's an entirely different league than even making the atom. And even then, it's a big proton, or whatever you want to call it at that point, but it's still not a zero volume object. It's still not a singularity. And therefore, I think that it's being kind of misused. That's just my thought.